Okay, so in these slides, we want to introduce the idea of how a force is applied on a wire when the wire has a current and this wire exists in a magnetic field. So here we have a wire and the current is going upwards, the direction of the current. Of course, remember, current doesn't have direction. So what we mean is the direction of J is upwards, current density. The magnetic field in this region, in this rectangular region, is pointing into the page, denoted by the crosses. And the question is, what will happen to this wire when you put it in this magnetic field? Think about it and see if you can find the solution. Okay, well, if you think because the direction of J is in the direction of the current, is J is this way, that means because the charges that are moving in the wire are the negative charges, that means the velocity is opposite the direction of J. So the velocity of the charges is opposite the direction of the current in this sense. So if you apply the rule that the force on the charge, on each charge of these charges inside the wire that are moving, the force is QV cross B, well, V is downwards and B is into the page. So V cross B is to the right. But then when you multiply by Q, the charge is negative. So you multiply by Q, the force becomes to the left then. So the force on the charges, on the negative charges, is pointing to the left. That means they will pull the wire with them to the left. Okay, what will happen if you reverse the direction of the current? Well, in that case, the direction of motion of the charges will be reversed, and now the charges will be moving with the velocity upwards. If you have charges moving upwards, then V cross B is to the left and QV cross B is to the right. So the wire will experience a force to the right, pulling it to the right. This is a nice video that you can watch online. It shows a demonstration of how you can put a wire with a current in a magnetic field and show how the wire force is applied to it and the wire jumps.